This lesson is about ratios, rates, and conversions. First, we're going to think about how we compare numbers. Compare your age to someone who is 34 years old. Think about how you would compare the cost of a car that costs $20,000 to the cost of a car that costs $50,000. And think about how you might compare my dad's height, which is 60 inches, with my height, which is 68 inches. Chances are you thought about it this way. If you're 14, you might say that the other person is 20 years older than you are, or you might have said that you're 20 years younger. If you're going to compare the cost of a $20,000 car to that of a $50,000 car, you might have said that one car is $30,000 more than the other, or one is $30,000 less. And if you were to compare our heights, you might say that I'm 8 inches taller than my dad, or that he is 8 inches shorter than I am. When we compared these two numbers, we compared them using addition or subtraction. So if you're comparing our ages, you subtracted 14 from 34 and got 20 to say that you're 20 years older. If you compared the cost of a $20,000 car to a $50,000 car, you subtracted $50,000 from $20,000 and got negative $30,000, which means that one car is $30,000 less than the other. And if you compared my dad's height with my height, you may have subtracted them and concluded that I am 8 inches taller than my dad. Now let's take a look at another way of comparing quantities. If we were to compare the cost of a $2 notebook to that of a $1 notebook, we might compare them using division. We might say that the $2 notebook costs twice as much as that of a $1 notebook. If we were to compare the cost of gas, which was 20 cents a gallon in 1965, to the cost of gas today, which is about $3.75, we might say that the cost of gas in 1965 was about 53 thousandths of the cost of the gas today, or about 5.3%. If we were to compare the cost of a college math book today, which is $120, to that of the cost of a math book in 1975, which is about $40, we might say that the math book today is about 3 times the cost that it was in 1975. These are 3 examples of ratios. A ratio compares two numbers using division. Here's some other examples of ratios and different ways of writing them. A boy-to-girl ratio in a class might be 3 to 2, and we can write that as a 3 to 2 ratio. We can write it as a fraction, or we can write 3 to 2. The oil to vinegar ratio in a salad dressing, for instance, might be 5 to 1, which is the way we'd usually write it, but you could also write it as 5 to 1 or 5 to 1. If we talked about the student to teacher ratio in a school, the student to teacher ratio might be 20 to 1, or we might say that it's 20 to 1, or we can simply write 20 to 1. Now, the two quantities that we're measuring in a ratio must be measured in the same units. So for instance, the boy-to-girl ratio in a class. Boys and girls are both people, so the units of the 3 and the 2 are people. In oil and vinegar, the units are ounces, 5 ounces to 1 ounce, or 5 gallons to 1 gallon. They're both measured in the same units. And student-teacher ratio in a school. Both students and teachers are measured in the same units, that unit being people. A rate is a special type of ratio that compares quantities of different units. Here are some examples of that. When we talk about the speed of a car, we say that the speed of a car might be 60 miles per hour. This compares the number of miles to the number of hours, and miles and hours are different units. when we think about how much work we can do, for instance, if we were making muffins and we could make 50 muffins in a half an hour, we might say that that is our rate, 50 muffins in a half hour, and that's actually equivalent to 100 muffins per hour. That compares muffins in hours. We might say we can type 70 words per minute. We might say that when you're babysitting, you charge $15 per hour. If you buy a dozen eggs and the eggs cost $3 for the dozen, how much does it cost per egg? Well, if we divide by 12, we would get 25 cents per egg. These are all examples of rates. When we say that a car is going 60 miles per hour, we mean that the car is going 60 miles in 1 hour, even if it traveled for less or more time than that. But if it traveled for 1 hour, it went 60 miles. And it also means 60 miles for each hour. When we state a rate as a this per that, like miles per each hour, we say that that rate is a unit rate. Now, if we went 120 miles in 2 hours, that's 120 miles in 2 hours, that's a rate, but the unit rate is 60 miles in 1 hour. 120 divided by 2 is 60, 60 miles in 1 hour. When we talk about 50 muffins in 1/2 hour that we can make, we make 50 muffins per half hour, but that is 100 muffins per 1 hour. So 100 muffins per hour is the unit rate. When we think about $15 spent on 4 gallons of gas, we can say $15 per 4 gallons, but the unit rate is $3.75 per gallon. That's $3.75 per 1 gallon. In problem number 1, we're going to look at why unit rates are important. So say you're shopping for t-shirts. Which deal is the best one? $25 for 2 shirts, $45 for 4 shirts, or $30 for 3 shirts? We can compare them using unit rates. At store A, we have $25 for 2 shirts, and that is $12.50, so $12.50 per shirt. That's the unit rate. In store B, we get 4 shirts for $45. So the unit rate is $45 for 4 shirts. That's $11.25 per shirt. And then at store C, we get 3 shirts for $30. So that's $30 for 3 shirts. That's $10 per shirt. So clearly, store C has the best deal, and we used unit rates to figure that out. Now, take a look in your textbook in Lesson 2-6 at the Got It for problem number 1. Stop the video and restart it when you finish that problem. Please do that problem in your journal. Now, let's do some unit conversions. In the first example, we're going to convert between inches and feet. So first we note that 1 foot equals 12 inches, and this is a good diagram to look at as you do unit conversions. If we want to convert 5 feet to inches, we need to know how many inches there are in each foot. Well, there are 12 inches in every 1 foot, and we can multiply that by 5 feet to get 60 inches. So now we know that there are 60 inches in 5 feet. Now if we want to convert 42 inches into feet, we need to know how many feet there are in 1 inch. Well, according to our conversion, every 1 foot has 12 inches. So that's 1/12 of a foot per inch. And we multiply that by 42, inches, and we get 3.5 feet. Next, let's look at converting centimeters to inches. Now, if we want to convert 15 centimeters to inches, we look at the conversion. 1 inch equals 2.54 centimeters. To convert centimeters to inches, we need to know how many inches there are in each centimeter. Well, there is 1 inch in each 2.54 centimeters. So if we multiply 15 by 1 over 2.54, we can get the answer to this conversion, which is about 5.91 inches. So this says that there are 5.91 inches in 15 centimeters. If we want to convert inches to centimeters, we need to know how many centimeters there are in each inch. Well, for that, we use 2.54 centimeters in each inch, and we multiply that by 10, and we get 25.4 centimeters in 10 inches. Now, stop the video and do the Got It for problem number 2 in your journal.